All right, welcome to our latest edition of Dredging Deep. I'm John Jones, president of Custom Dredge Works. Today with me I have Lou Nash with Measutronics, and we're going to have a discussion today about Measutronics and Custom Dredge Works relationship and sonar in particular. I guess to start out with, Measutronics is our provider for our sonar systems. We have a relationship with them that's been developed over a number of years, and we're proud to be partnered with them in providing sonar and positioning equipment on our dredges. And Lou's been a great help to us in getting our systems lined out, and just a huge, just a great mind in technology, and in particular this kind of technology. But I'm going to let him elaborate kind of on the history of where he started with the sonar side of his business, and roll through it. I understand it started sometime around 2002, 2003?
2003, John, yeah. So, and thanks for the intro. And then what you see in front of us here is our new multi-beam sonar system. It's called InSonar. We just got it last week. It just came up. It came out of the water yesterday. I wiped it off, dried it off on our way to the airport, and here we are. And we'll talk about that a little bit at the end of the podcast. So yeah, for us, we're almost 30 years in business now, and it was 2003 that really I saw the utility of sonars, multi-beam in particular, on construction barges. And that was a project. I'll show you a couple slides here. That was a project. What you're seeing here, a rock cover placement on a pipeline. This was a Weeks Marine. We weren't responsible for the sonar portion of this project. What we were doing was the guidance, putting the barge in place. There's a conveyor belt that rock comes from a hopper, and making sure the conveyor's above the right place on the pipeline, and we're tracking the rock as it's going out. And then what you see on the right hand side, the sonar portion, which was all contrived and facilitated by Weeks Marine. They put up what then was just a classic multi-beam on a rail, and the rail ran up and down the side of this rock lay barge. The cable was all strung out there in a festoon type way, mm-hmm. And it would go. Once we felt they had the rock in the right place, then it would call for a quick scan, a survey, and the sonar would run back down that rail. Then they look at that 3D surface, and over time make sure they had the right coverage. Where they were short, where they didn't make enough rock for grade, they would we'd have a station offset. We could position them back to that station offset. Mm-hmm. They drop the additional rock, make a scan again. So the point was to make sure they weren't ever going back because they didn't make grade. So that's kind of when I started thinking of these things, and my first real exposure to it, other than outside of traditional multi-beam survey vessels. Just the sonar on the barge, it registered then, and I just started thinking on it.
So you'd say that project is like what really whetted your appetite towards the sonar into the business?
Yeah, it did. It showed the utility, the value, and all of that multi-beam then was, it was half rocket science, half luck, and then you still had to have a rabbit's foot sometime to make it all go.
Right.
So it's come a long way since then. Yep.
So the next project then, from there, what did you do? What was the next big push?
So it was several years, and here you'll see, I got involved in a lunchtime meeting with a contractor on the West Coast. And he said, "Hey, we have to. We're building this fish attraction structure on the river, and it was Idaho, I believe. And they had to have, had certain design and where they had to place this stone. So they had a moon pool barge, and they would and a long reach excavator. They dropped the stone." And typically, what they'd said in the past, they would use their long reach just to touch it. Their machine did have some guidance systems on it.
Yeah.
And they would touch it and kind of as-build it as they went. But in this particular instance, the depths were, beyond where their long reach could reach, beyond its touch. So we came up with a system. The conversation I was in, they said, "Hey, we've got to do this, and we got to start next week, and we don't have budget really on doing it, but we don't know how to do this at all, how this is going to work." So we put together a system where we suspended a multi-beam, small multi-beam sonar head across the moon pool, and then the machine had guidance on it. And we used that, but then we used our old school Trimble Hydro Pro for we created some cells, and the operator would put a certain number of rock drops in each cell that was calculated to where he felt he would make grade. And when he had finished with that cell, we triggered an event. We'd mark the cell with a dot, meaning, okay, now he goes to the next cell. And when he completed all those cells within the reach of where the machine was located, what the moon pool would give him. Then we physically ran this sonar across the moon pool. It was a two-man operation. Two guys, one would push each of those antenna poles you see there, and so that we capture here in this video, and literally these two guys push it across. We get the sonar data. We then have to capture that. There's a third software involved for that. So now we've got three softwares going here. And there was a bit of data processing and such, but again, the concept was make sure they made grade before they move this barge.
So this let them place the rock and check it, utilize sonar to see what's there, right? So they could do it as you went and didn't have to go back. I mean, maybe they went back later for one final check, but just to get a grand scope of the entire project. But they knew what was already down there because they've had just already seen it.
Right. They had to scan it with a sonar, make sure they had met grade before they kept moving down the river. They don't want the surveyor to come in next week and say, "Hey, you missed grade by X feet in Y spots."
Right.
So they make sure they've made grade before they move to the next structure.
But the downside in 2014, you managed to integrate all these tools and then three different softwares.
Three different softwares: the guidance software on the machine, which they'd already had, our Trimble Hydro Pro for the cells and the events and some of the things that the guidance software is not set up to do. And then we had we had IPAC bringing in with High Sweep, bringing in multi-beam data that had to be processed and then sent back to the excavator. But we streamlined that process, but it still did. The machine wasn't working while we were doing any of that. So yeah, two men to push it, three softwares, and then the guy running the software as well.
So it was kind of an operation to try to make all that work then.
It was a lot of balls in the air. Yeah, there was a lot going on.
Right. But still way faster and way easier than having to move out of the way, conduct a traditional survey, right? And then move back into the spot again.
Yeah, and these guys were remote, and the surveyor, it was third party, so they have to wait for them to come in and get this done. So this system eliminated any surprises when a surveyor came.
Right. And through this project, I mean, you got a wealth of experience right off the gate. I mean, this thing here taught you quite a little bit about it getting it going, did it not?
Yeah, and more so, it pointed out there's got to be a better way.
Better way. Yeah.
So we kept striving towards that. Yeah.
I got you. Okay. So then the next project was,
Yeah, so I guess next right after this, and here I'll show you, there was a conference. Teledyne had a conference in Boston on different technologies, and marketing materials were starting to show up that reference this 3D scanning sonar, right? So I went there to see what it was all about, and really just to confirm that it was beyond the just marketing brochures. And then I looked at it and I said, okay, if we could interface this to our thermal guidance, if we could get the two of those together to talk, then we're there, and yeah, that's when I knew it was viable. The Idaho project told me it was worth figuring out.
right.
This showed me it's viable, and we're probably a lot closer than we had started in Idaho. So next for us, we did get together the Teledyne and started interfacing that, and we're able to get it down to two softwares. They have a software for the excavator guidance, and they had a software for the 3D scanning sonar. So we got it down to two softwares. And here is the first, I guess, production job. We had done a lot of things in beta, but this would be the first production job that we had put all this together. And this is an excavator. Again, this is Weeks Marine. But they put this together, excavator to place stone under a number of bridges that had been kind of washed out during Hurricane Sandy. So you can see here on the upper left-hand image, the green is the deeper, that's the scour, and that's what we're there for to correct. So we mounted sonar on board this barge and had it all tied into the excavator guidance system. And a few things we got from this project. Here, when you look at this image, this is the sonar scanning, and you can see right there they just had dropped some rock, and you can see the plume come up. Because we've always gotten a lot of feedback that, hey, there's a lot of suspended materials and acoustics doesn't like that, but you can see the recovery here. We're already starting to see hard bottom again through there, right? And the sonar did do a good job of delineating that. So, it's not really slowing down our work. I mean, this is a real time what you're seeing here, and there's hard bottom already, right, in the scan. So same thing, they're dropping a rock and seeing where they are relative to grade. And then I thought it was interesting after this project when we had taken the unit off. All that suspended material, that's the sonar head and the rotator unit. The pan and tilt, and you can see all the dirt that got up under there, the sand and stuff. So let's see how it's in a rough environment, and it did work, and that's a plus. The turbidity argument, if you will, we were able to dispel that and say that, hey, this really doesn't slow down our work. And when you think about it, especially in this instance, they're there because of scour,
Right.
Meaning there's some flow. So, the stuff that gets put into suspension, it's not there too long that it's downstream, right? So that we were able to dispel that issue. It was kind of a non-issue. But what we also learned here is the pan and tilt that we had, it really wasn't made for the duty cycle. It had to keep, and a lot of things, nothing then was made for this purpose. This was all new kind of applications, right? So we took what was available and we made it work as best we could. But, with that, we learned some lessons along the way. And one was that, the duty cycle of these things really, really matters because what was available then was just not meant to work all day, every day, day after day. It was made for occasional scans, not guys dropping rocks and every third drop checking grade.
Right.
So we learned that. And then really from there we went, next project was a structure placement project. They were retraining the river, putting these massive concrete structures in place. Excuse me, and they had to set and establish subgrade, and then again make sure it's to spec. So they were scanning it before they were putting these big, massive pieces of concrete in place. Here it worked really well, and the sonar. They had 2 sonar systems working on this project. This is Manson Construction, and Manson has some really advanced sonar capabilities and operators. They were taking it so far that they were almost they started calling these as-builts as they were scanning, and we were like, whoa, wait, this is not what we're trying to do. We're trying to make sure you don't have surprises when the surveyor, when a third party comes to do the as-builts. So we had to coin the term and make sure our guys were using it as building.
I see.
We wanted to measure as building. And again, that eliminates the surprises when a surveyor comes. It eliminates the rework, reduces it greatly, if not fully eliminating it. And because of that, it controls the cost. They don't want to go back. So that was a positive, the as building aspect of this. One of the negatives we learned here is they had just like the other project, the first project there, the original system was a 1350 kilohertz sonar, which, the physics of it's really great resolution. But the range is somewhat limited. And it was spec'd, I think, at 30 meters. 30 meters, we soon learned means you can get a return, but not much resolution. And what we saw, we had a sweet spot. I'll switch to feet. We were about 70 feet was a sweet spot as to getting the resolution to really see what they needed. But what happened here was when they finished this project, they went to their next project, and they needed. It was a deep channel with a steep slope, and they needed to place stone on the slope. Wanted to see that the stone wasn't all rolling to the bottom of the slope, but the bottom of the slope was just outside of our reach with the sonar.
Right.
So, a little bit of disappointment there, and that it was kind of a one and done system at that time.
But in 2016, was that not the kind of the average unit that was available?
Yeah, that is what was available, and and again, but it wasn't made to do these things,
Right.
So again, we were taking off the shelf hardware and software and integrating it to get done what we needed.
And
right?
you were using Trimble stuff for that.
Yeah, it was all Trimble guidance on here.
So when did the TMC software start to play into this?
Okay, so here we were still with 2 softwares, Teledyne PDS. There was a software for the excavator, and again a software for the scanning sonar. And 2017, at the end of 16, the beginning of 17 is when Trimble and Teledyne made an OEM agreement where that they created TMC, Trimble Marine Construction. So there's a licensing agreement between Trimble and Teledyne, and now though we got it down one software package. So we had one software that runs the guidance on the machine, and that machine can be your cutter head dredge.
Right.
It can be excavators, placement materials. It can be clamshell cranes. So one software is taking care of the guidance, and then that same software is able to receive this sonar data. And what that's doing now is bringing real-time feeds into the operator's cab,
Right.
and it's updating his surface. So all he needs is a scan. He's got the surface now. We compare the sonar surface to the design surface, and computed third surface called deltas, the differences.
Yeah.
And it's a heat map. Where's the high spots? Where are the low spots?
Right.
And now the machine operator, if it's high, he can knock it down. If it's low, he can fill it. So now we're down to one software.
One software taking care of
Yeah.
a multitude of equipment. And speaking of equipment, yeah, I mean, just on the way in from the airport earlier today, we were noticing just every piece of equipment we drove by, bulldozers and excavators and all that equipment, they all seem to be stacked with the Trimble units. And we were talking about how, gosh, just it seems like just a few years ago you would rarely see it, and now it's just exploded through the industry.
Yeah, and that few years is probably 15, probably closer to 20 years. And here I'll go to another slide, and this shows in the earliest days of machine guidance, and that's where really when I got started in business, I was doing some of this and putting, and then it was GPS, right? There was only
Right.
a single constellation, and we're putting that on bulldozers in the phosphate mines doing reclamation work. And it was common then that contractors would say, why would you put GPS on a bulldozer? And yeah, now it's, that was maybe 20 years ago, but the utility of it and their mindset, the contractors is only touch the dirt once,
Right.
and that makes them more efficient, and it makes the job more profitable. And as that caught on, the question went from why would you put GPS on a bulldozer to how can you not have GNSS on your dozer?
Right.
And so you're right. As we were driving from the airport today, there's lots of equipment out there, big yellow machines, and lots of them do have the Trimble guidance. Trimble has, they really do dominate that market.
Well, on the dredging side, of course, we obviously manufacture a ton of dredges here. Just on our side of it, in the last, it's the guidance side of it has become a standard option. It's not even an option. You just, when you buy a new dredge, you get positioning. Now, I feel like that it's the same thing in the dredging world. I mean, we're used to the machines didn't have anything really. They would come in and do some kind of a site survey through the job for as building, right? That sonar may come into that, or is going to come into that, to allow more as building data to come back in and help on the dredging side.
Yeah, and where you're at now, John, really is, and because I did kind of cut my business teeth seeing the machine guidance come to be, right? And become commonplace.
Sure.
And I can look at it and see lots of parallels. And here we'll look at the technology adoption curve, and I've put on here these timelines. 2003, that's where you and I started this conversation, and that's with the innovators, right? That's their portion of the curve. Not many guys out there wanting to be first.
Sure.
But Weeks Marine has done it a number of times, and they do it well. And then as you go across and up the adoption curve, you get to the early adopters, and that's kind of where we picked up with our rock dump project in Idaho, Manson, some of those other ones. That's now the technology's getting a little more of a track record. There's a history. There's some referrals. Some references.
Right.
And it takes time. And now this slide, I looked at it in. My thoughts are that in 2020, what's the middle section of the curve here, the I'm sorry, the early majority. In 2020, we started seeing more manufacturers with offerings, dredge manufacturers with not just the GNSS on their dredges, but the sonar, right, to do their real time updates. We're seeing sonar manufacturers put together packages built for that,
Right.
or more towards that. And to me, that's the signal that it is we're in this early majority phase. And then for us, it just happens. It took us for a number of reasons. We're about 2 years into our sonar development,
Right.
and we went at this kind of purpose built. We learned all these lessons along the way. This does work. This doesn't. We know what the pain points have been. So we built. We had our sonar built in mind of that, right? So we've got a small, compact, rugged unit. The inertials, so the IMU for measuring pitch and roll.
Right.
It's all internal to it. That takes a lot of the error propagation out. It just makes it easy to install and get up and running, right? We've named it because of that. The INSONAR, INS, Integrated Navigation Simplified, right? So we've got that topside unit. We've got a single cable that goes down to the sonar head, because we've known over the years that any cables and water and salt water and electricity over time, that's not a good mix.
Pretty much all the other systems have multiple cables.
Yeah, that's fairly true. And so we've eliminated one of our pain points there, right? One of our points of failure. We've reduced it, right? I mean, cables will fail. It's just salt water, electricity,
Right.
And then we've got now with the development of Trimble's RTX.
Right.
I mean, all the dredge systems we put in for your customers, we're relying on that Trimble RTX.
Right.
And our internals here, this is an Aplanix IMU, which is Trimble, and we're compatible with the RTX. And the way our guys describe it, you get it set up, it comes in through the GPS L1 signal. You get it set up, you turn it on, it's just there.
Right.
You don't even realize what's going on, but that fixes that takes care of a lot of issues we've had in the past. What the vertical datum is, and what they're tracking, how they're getting their vertical reference.
Right.
It's not done real well in the industry, and this just takes care of it. It makes it go away.
It's a simpler setup. It's also got possible multi-uses, right?
It does, and it is simpler. And one of the issues we'd had and experienced was we've come to plenty of project sites where what you saw up here, some of the references were some big projects.
Yeah.
And the price of kind of upper end multi beams and all the accessories to go with it was justified, right? I mean, all the ones we put in, nobody ever wanted to give them back, right? They're using them and they're getting their value. But there's some projects they just couldn't get past that price point. They couldn't justify it for that project. So part of our criteria in having this sonar built, and we went to Norbert. Norbert built this for us, and we said, look, you've got lots of sonars with functionality. You've got lots of functionality that our customer base doesn't need, doesn't use. And quite honestly, we try to hide those buttons. So he said, let's build a sonar, take away some of that functionality, and with that, take away some of the cost that's behind that.
Right.
So we've kind of spec'd this down to where we're comfortable. myself and our techs, we went through this a lot and trade-offs, plus and minus, back and forth. But we think we reached a level of specifications, performance that that meets our needs, our customers' needs, and that the price point accommodates that.
So it provides a quality unit at a value price that also delivers exceptional, maybe not high-end resolution, but exceptional resolution.
Yeah, it's fully adequate for what we need, and it is quality. The again, the acoustics are by Norbit. The inertials are by Planix, which is Trimble, and our RTX corrections, our positioning is by Trimble. So
Right.
it's all top of the line manufacturers that have been a part of the development of this. It's their product.
And you're gonna this at least for our product, there is a rotator that we would use to rotate the head to get a wider swath with this piece, and that piece is I know because we build it, is rugged and very industrially built. So it's made to live in a. Of course, we built a lot of dredges for mining. It's made to live in a mine environment, whereas prior like pan tilt heads are a little more delicate.
Well, I don't know if they're more delicate, but they're kind of over engineered for what we're doing.
I see.
And they're priced accordingly, right?
Sure.
I mean, there's some out there that are made of titanium. And, we didn't ask you to build a submarine hatch.
No.
We're asking you to build a unit to rotate our sonar head. And why, getting back to the simple part of it, the, integrated navigation simplified, when we put this unit on a survey vessel, we use Norbit's Portus pole. And what that means is the sonar head's at the bottom of a pole. The pole is, regulated length.
Mhm.
It comes up, it goes into a yard arm type arrangement that separates our two antennas so that they're spec'd at 2 meter separation. That's where it's at. And when it's on a survey vessel, because the IMU is at the bottom end of the pole and the antennas, our heading is at the top.
Right.
We're measuring all the motions, so we've got everything we need. And now what we've asked you to do is make a similar pole, so that we get it over the edge of the dredge or the construction barge into the water, the sonar head, directly above. We've still got the pole coming up to our yard arm, our 2 meters of separation. But because we're taking our heading from there, we're just asking you to rotate the pole.
Right.
So when it rotates, we're still
good.
getting the measurements. We don't need another piece of hardware with encoders in it and built of titanium to do this. So you're building this a system out of 24 volts, and all components that our guys can service.
It's dirt simple.
So
It's dirt simple.
It's simple. That's what we want. And I think you're calling it the simple rotator.
It's a simple rotator. Yeah, that's what we call it. Yeah.
So yeah, we simplified everything based on the lessons we learned, and it did take a while, and not all those lessons were easily learned. But we wrote it down, we made a note, we made it better.
We are sure proud to be partnered with you, bringing this into the dredge side of the business, and bringing it to our customers. I know there's already been quite a little bit of interest, and we're excited to get them out there and get them working. So I know that we've got a few more tests to run with it, but all in all, it's pretty much ready to go. It will be the system that rolls out here, and what we will be providing over the next few months.
Yeah, just a few more tests, and then we've actually got some things on my secret whiteboard, John, that we're going to go make this even a bit better. So
Yeah.
So stay tuned for that.
Right. Well, we have big plans for it as well, as because ultimately the idea is working towards an autonomous dredge, and getting this data back and into our systems to be able to to possibly apply AI to it to, get the machine to learn how to run itself sooner than later is definitely a big push for us. So, Lou, I mean, I really appreciate you sitting with me here today and going through this. It's been interesting, man. You're a wealth of knowledge, and I really enjoy every time you come down to sit with me and do these. We've worked really hard on this over the last couple of years. We've had ups and downs trying to put it together, but finally we've come to the point where we have something that is really, really good and provides a great value and is really, really saleable. And I'm excited that working together we get to bring this out.
Yeah, us too. And it is where it needs to be now.
Yeah.
And we just need to get it out there. So
Yeah, I'm excited about that. So, man, thanks again.
all right. Thanks for having me up, John.
Yeah, good deal.